quickly, what was our approach? Let me make
Can
a
we
quick
start?
run.
Can you show the question once, Shivani? So it will be a recording, so we can put it up. How did we even
Chetan, like,
reach?
where are you actually updating all the recordings and like, are you sending it over to someone or?
Yeah, it's on the Google Drive. The link is in the Discord. So what happens is I send recordings to Rishabh. Rishabh cuts them down. He uploads them to Google Drive. So there's this drive where every discussions we've had, those discussions are there on that Google Drive. He has listed them nicely.
Cool.
Yeah.
I guess
Question,
editing it out is a large task, yeah.
question number 3 is the question we are dealing with, I guess.
Yeah. Question not question number three. The question
Mhm.
number four. Question number
Yeah.
three. And four. Yeah. Question number 3 and 4. Yeah. Right.
Mhm. Fine. The approach we were the thing was that, let us go one by one. When we read question number 2, it comes out that there are two equations and two variables. So we find the value of A and C very easily. But what happens when the number of variables remain the same and the number of equations increase? What happens that there is no solution. Prima facie, there happens to be no solution to this
Right.
problem. But given the real life scenario, if any businessman comes out with such data where number of variables are less than number of equations, what do we do? We say that, okay, this is some la la land problem, we cannot solve it for you. No, we do not do that. We have to find the best possible answer.
Okay, la
Okay.
la land.
Okay, so we have to find some solution. So what would that be what would be that solution that we can give to the shopkeeper or a businessman so that he can maximize on his profit? That is to say, we have to find the best approx solution.
Closest approximation. The best
The closest,
approximation. The
closest
min.
approximation. For that, what we did is that we plotted these three equations.
First, what we did is that we plotted the two vectors, found out whatever the plane that spans the two vectors, and then we know that 1200, 1900, that point is not that point would not lie on this uh,
Plane
plane spanned by the vectors.
vectors.
So we drop a perpendicular from 1200, 1900 to the plane.
And find the intersection of plane and the perpendicular.
Yeah.
Yes. So then we just solve with those
So
because
like we could try that out on GeoGebra too, because I guess Chitturaj
And
is the meat.
and afterwards, what they did? Afterwards, what we did? We found a point of intersection of perpendicular and the plane.
yeah, and
And
then you
afterwards,
got an elimination and then all.
That is, yeah, that point happens to be the best possible answer for that equation.
Yeah.
Best possible approximation.
no,
So
no,
we
we
equated
were
the
we were
equations to
we were we
that
were find
vector, which is
we
our
were finding
approximate
A
vector.
and C, na?
Yeah.
Yeah, we were approximating A and C.
We were approximating A and C. We were not supposed to find that point.
No, we were supposed to find what A and C takes us to that point. Yeah.
What
Yeah,
A and
that's the
C
correct
takes
one.
us to that best possible point. That is the best. We have found a best possible a point which gives us the best possible solution, and then afterwards we find A and C by solving by Gaussian elimination of matrices. As
Correct.
simple as that. This was our approach in a quick run.
Right.
Maybe we can quickly maybe
Demonstrate it.
demonstrate it via GeoGebra.
Yeah. So I'm hoping that everyone understands how we came here, and then I'm just going to start with this, right? Is that okay?
Yeah.
Fine.
Yeah,
Yeah.
please.
Okay. So we're taking the two vectors. So ideally, we're looking at the column picture. We're looking at the two vectors, and the second vector is
1 to 1, 1 to 1, 1 comma 2 comma 1.
Yeah.
And third point, a point
that
1200, 1000 and 900, and a plane comprising of u plus v.
Yeah.
So this is the point we want to reach. Am I not able to? Oh, it's a very, very large number.
Now
Yeah,
let
but
us
sir plotted it
that,
just to get us 12, 10, and 9. So we'll just get.
Yeah. So we're
Yeah.
just scaling it down to 12, 10, and 9. That is also not here? Maybe I should zoom out.
a bit. Now it is there.
Yeah.
Let us
Okay.
Now just get the plane, then it will be fine.
let us
Yeah.
I
find the
guess
plane.
now we have to draw a plane. Okay, which
Maybe
Okay,
we will quickly, cover a very important concept of linear algebra, linear combination here.
Yeah.
That how we come up with a plane concept of plane. How combination of two vectors leads us to a plane after plotting is done. Let us find a plane.
yeah, yeah. So I mean, the way you find the equation of a plane is something like we know that the slope of the plane will be in the direction of v minus u, right? Isn't that one way we can go through it? Like it will be in the direction of v minus u, and it passes through u or v, and then we can just solve, right?
No,
Oh,
in
I would
GeoGebra
just
we can
say,
just
yeah,
in
yeah.
GeoGebra we can just give it a
just use
function.
plane off, I guess. No, just do plane
Oh,
off.
okay. Like
Let me check this. I'm not sure. Plus,
No, I don't know.
Yeah, that would work. That would work.
You can do plane off, in fact. Easier, I guess. And then one is 0, 0, 0, and then the other two. U, V, 0, 0, 0.
okay, that is the easy way. Yeah.
U and V. Okay.
There you go.
Now you have
Maybe now we
Now,
can
how do we
see.
drop a perpendicular?
No. First of all, we must and show this that there is no any way possible that A will lie on this plane.
Yeah. Can you plot A as well?
It's kind of
take
we have plotted the plane
the point is clear.
and A,
Right.
so we can see that they don't lie on the same.
You just are somewhere. If you zoom out, it's clear. That's it. There's just a lot of gap between them. Yeah, that's it.
Fine. The plane has crossed this point and it is not lying. The point is not lying on that plane. So the problem at our hand is that
Yeah.
we have to find a solution such that
The closest point on the plane to this point A. Right?
Yeah, so that you can solve it.
no, we are going to
Yeah, like
find the closest point on the plane that is closest to the A point.
Yes.
And that happens to be perpendicular from A, of course.
Yes.
Perpendicular distance is the shortest distance, we all know.
Yeah, to the plane, perpendicular to the plane. Yes.
What have you done when you wrote P perpendicular plane 0, 0, comma the points?
That's just okay. That's
Perpendicular plane was why I
no,
got
no,
confused.
no. You can create it with.
This is automated, I guess, na?
It's automated. It's automated.
Nah, he only wrote plane.
Yeah, it is just automating it. When you give two vectors, just does U cross V and then perpendicular planes. Yeah.
Okay, I guess
That's
the
fine. That's
logic
fine.
to that
because
is
Same
that
plane.
because of U cross V, it is saying perpendicular. That is not an issue.
That's fine.
yeah, if U and V are on the plane, the vector U cross V will be perpendicular to the plane. So
And then it's just like this. What they want. Something like that.
to plot the plane, you need the one point and the perpendicular.
Yeah, I think Chitura again helped us through.
Okay, let us drop perpendicular from point to that plane.
Yeah.
Point plane.
Vector.
Perpendicular line, not vector.
Vector, I can't use it. So that
No,
can't go. Okay.
perpendicular
Yeah.
line.
Point plane.
Point plane. Point happens to be A and plane
And
is
P.
P.
Perfect.
There you go.
Now you have to get that point on that plane.
Point of intersection of plane and perpendicular now.
I think there's an intersection something.
Point.
Intersect. It's called intersect. No, intersect.
Intersect.
Yeah.
Intersect, point and plane.
Object.
Fine, object.
Yeah. And then you just put the point.
A, comma, F.
No, it's not A.
Hmm?
A comma P, na? It's A comma P.
No. F comma
Yeah,
F
sorry,
comma
it's A
P. It's
comma
F
P.
comma P.
A comma P. A comma P.
No.
Intersection
A
of we are finding intersection of perpendicular and plane, na?
Mm-hmm.
Yeah.
So the perpendicular is
Right.
P.
Mm-hmm.
And plane
Yeah.
is
We got the point,
Yeah.
right? We got the point B.
Yeah, that's it. So now
Not different.
that
Yeah, it's P comma F.
P and F.
I'm not able to unselect the. I'm not able to. I don't know what happened to JGBra. I'm not able to like.
Yeah.
move your mouse.
Let it
Anyways, we have got this, the
Right.
points, the coordinates. Maybe
Yeah.
replace 12, 10, and 9 now by actual values.
Now, yeah.
There you go, 900. Enter.
Now you have to just zoom out completely. Just keep on zooming out. That's it.
Yeah.
Full. Yeah. You can go till 1800 something like that. You can keep on zooming.
Not actually.
There is no point in visualizing.
That's it. There it comes. That's the one.
This point. This angle.
Yeah. That's it.
Yeah, very good.
That's really nice. Yeah.
Very nice view, isn't it?
Mm.
You exactly see a perpendicular dropping on a plane from a given point.
Yeah.
Now this is
Now
this is the nearest possible point. This is the nearest possible point
from A.
which we can approximate the solution to.
Yes.
So now we will write down a system of linear equation
By substituting 1200, 1900 with this point. That is 1243.33 and 1086. That you just should that instead of 1200, that vector, then you just have to solve. That's it.
Yeah. So we have to find what factor to scale. So we have two vectors. 3, 1, 1.
1 to 1.
And 1 to 1. We need to know what
Point.
factor we need to scale these two and add them to get
to
Those
That 1243.33, 1086.67, 1 and 683.33. Yes.
this can also be written as a matrix as we saw before, but since we were looking at the
I think we also tried like we could try this too. The A transpose
Now,
A method.
yeah, we'll do that. Now we just did Gaussian elimination, so we subtracted R3 from R2.
Yeah. So what was the idea behind that? The idea is that, I mean, yeah, I mean, yeah.
We
I
wanted
think
to
it's
make at least something zero so that we can at least start solving.
so
R2,
one.
yeah, R2, R3.
R3 minus, sorry, R2 minus R3.
The R2 minus R3, you do then
0, 1. It becomes 1 minus 1 is 0 and 2 minus 1 is 1 and 1,
1,
1, right?
yeah. And then that side also you need to do, I think.
Yeah, so 1,
1083.
2, 4, 3.33. Now we need to subtract 683 from 1086.67,
Yep.
which
Yep,
is
1086. Write it down, no? 1086.67 minus 633.33.
403.34. 403.34.
that's okay, my mouse totally stopped working. I don't know why.
Should I annotate or help it like that?
No, maybe I'll just work with it down. Is it okay? I mean, because it,
Yeah, yeah.
yeah,
403.34.
becomes 1, 2, 4, 1, 2, 4, 3, and 3, 3, 4, 0, 3.3.
3.34.
yeah. And 683.33.
Yeah. Now,
Now we can see our
C is equal to
becomes
403.33.
4033.
yeah. C is equal to 403.33. And then
Once
A,
we get our C, we can calculate our A as well.
yeah,
Now we
with
can
the
put
last
value
two.
of now we can put C in the third equation.
Yep.
R2 is telling us 0 times A
A
Plus
plus
1 times C is
Right.
403.3. And then, so C equal to 403.33.
Correct.
So then R3 is telling you that
That A plus C equals to 683.
683.
So
1A plus
A
1.
becomes 683 minus 403.3.
This is 280.
That is 280.
therefore A is equal to
280. So this is how we get the 2 points A and C.
A and C.
yeah, so finally 311 and 121 of 280 comma 403.33 land us at
That
1
Right.
3.33 and 1086 point. 1086.
Approximately.
this
And
these
then,
two equations are these two equations are
Approximately satisfies.
no, this is satisfied completely.
yeah, the
Yeah,
1,200, that equation only is it's approximate.
Yeah,
Okay, yeah. Right.
so this is
Yes, it's because it's
completely
1
solved.
by 3, 2 by 3,
Yeah,
and
yeah. That's
1
so so how much time did it
by 3. So
take
when we
us to
convert it to
solve
decimal,
this?
nice question.
With,
Nice question.
with humans, it took 10 minutes to solve this. With computer, I don't know how you can write algorithms like this for you to
Very
solve
good
anything.
question. Very good question. How to generalize this sort of questions?
Yeah.
Okay, there are two, you know, kind of voids to say in our
Okay, I'll
approach.
stop the
First,
recording now.
no, do not stop the recording.
Okay.
This is a very important point we are trying to make, that it took us 10 minutes or maybe more than 10 minutes,
Oh, it took us more.
to, more than 10 minutes
It was the
to
first time we
come.
came up with it.
And for the first time, it took us even more, much more actually. But we knew the steps, which steps to follow after which step.
Right.
Then we came to the solution, and it took us more than 10 minutes. Fine.
Right.
And another thing is that we used GeoGebra. We had no mechanism in place to find intersection of perpendicular from a point to a plane.
I think we do, like, in geometric terms, it's the projection, right? So there's a formula
Yeah.
to calculate projection.
Okay, once again, even if you have that, okay, in what way are you going to say that, substitute R2 minus R3? Do this, that part again is going to be very tough for you to say this as an
Yeah,
algorithm, because it's going to
the
differ
solving part,
everything.
I think we could only do it because, like, if we had more equations or if the system was like very
We have intuition. We have intuition that the system, like, computer
complicated.
lack. Yeah. So that's the thing. Finding perpendicular, I think, see, again, as Maria is telling, I think there's a formula for you to find, the projector of the point on the plane. I think there's even formula for you to find the image of a point on a plane. Those kind of stuff exist. But those, even after the existence of those formulas, for you to solve this equation, right? That's where this comes in, because I don't know how you solve the
Yep.
matrix.
Yep, that is the point. That is just an intermediate step in our solution.
Yes.
Okay, when if we deploy a formula and we get to the point, which is very much possible, how do we get the values of A and B afterwards?
Exactly.
So
Yeah.
there is a hint that approach of so-called QR factorization could help us. So our
I don't
next,
remember the steps. It was quite complicated, wasn't it? And you needed some intermediate result. I don't remember exactly.
no, there is
I'll explain a few days.
so there is an approach that approach is called, I'll tell you the name of that approach to for solving QR factorization. It is Graham and Smith's process, or that is to say
Actually, Gram-Smith
orthonormalization.
process is not for QR factorization. It's for, like, if you have if you have okay, let
That
me
is for
see.
orthonormalization, isn't it?
Yeah, orthonormalization.
And we solve QR factorization with the help of orthonormalization. I guess so. Anyways, these concepts are involved in there, and our next topic of discussion would only be this QR factorization.
Shouldn't we try out that A transpose A method that to solve it? I don't know.
That is QR factorization eventually, I guess.
Is that? Oh, I didn't know. Okay.
Yeah. So that leads to orthonormalization and all. Anyways, we'll see as we trade forward. Now Chetan, we can, I guess, stop the recording because we'll first do